Okay, great. Hello everyone, sorry for the delay. Today I'm going to talk something about security from a different angle. Normally you don't see probably such topics. It's going to be a bit technical, but please feel free to ask later for questions. The topic is about the count model meets UTXO model. We as engineer, we probably very familiar with these two models in the blockchain world. But today I'm gonna do how to leverage both for better security. First, a bit about myself. I'm the founder and the core developer of RFU. RFU is a new sharded blockchain combining account model and UTXO model. The sharding is operational in production. Mainly launched since last year and is working really well in production. And my background is in 2015 I proposed the first leading time asynchronous presenting consensus algorithm, and I researched about number theory and the consensus algorithm in the universities. So my background seems to be very relevant to blockchain. Now let's get back to the topic. Security. Security is one of the most interesting topic for right now for all of the applications on blockchain, especially for DeFi. We have seen almost like big hikes almost every month. It has been like people have trying to kind of solve this problem for a long time, but still right now. Solidity auditing is time-consuming and expensive, even though that we kind of recommend every project to do auditing. But you see on the list right, on the right, like a lot of projects is not audited. Yeah, the efforts people have tried to improve the situation. There are a lot of such kind of efforts. The first very natural movement is to improve the tool chain and to recommend best practice for all the dApps. But this comes with some cost. The first thing is the learning curve is really getting much deeper. Especially right now, a lot of projects they use assembly language to optimize the gas fee. It's getting tricky and tricky. And it's very hard to scale the development of the apps because you need to learn a lot to write a secure the app. There's some approaches, more thorough approaches to improve the situation, like introducing new transaction model, new virtual machine, new contract languages. I'm sure that you have seen a lot of these trials in the past. This approach sounds like more kind of try to solve the root cause of the issue, but it comes with a cost as well. Like bootstrapping is hard. You need to educate people about the new infrastructure, new stack. But for the long run is great because if you see the evolution of programming language, we start with assembly, we start with C, but after 30 years probably, we have Rust, and it took many years to make Rust mature enough for production. I think it's going to be the same for blockchain. We're going to see base transaction model, base VM, and base languages. Especially I want to mention in this huge category, there's one thing I really think is very promising is to leverage the UTXO model for security reasons. First, a bit recall of account model and the UTXO model. Account model is basically, if you see the blockchain as a huge state machine, the transactions actually have direct access to the state. The transaction can modify the state of for example, the Oracle, modify the state of Uniswap contract to store the information of the price of the pair. And UTXO model is completely different model. Is you can see it somehow like the pure function in programming language. Each each function, each transaction is a function that consumes input and generates output, and there is no side effect, which means usually bad security in this case. Side effects is usually very hard to deal with. So, like this, no perfect model in the world. Here is a short list of the comparison of both models. So account model is the biggest advantage is, as we have seen from the EVM ecosystem, is that it's very friendly for developers because it's very close to how we write codes in general. It's expressive and flexible. You can build very, very powerful applications on top of it. It has a small transaction size. But the problem is the state is very mutable, you know. Like mutability is a big issue, a very challenging issue in general for programming, especially for crypto. Even if one of the operation that's muted states is not really tested or is not really like taken care of, it can be really a problem. By default, the security is lower. And another issue is account model is hard to execute in parallel. But on the other hand, the UTXO has some advantages. The UTXO, like Bitcoin, all of the output, they are owned directly by the users. It's more kind of decentralized. If you compare to account model, is basically your token is controlled by the contract. For example, the ERC20 token, all of the states are in the contract. So UTXO by default have this security advantage. And another thing is the model is very kind of explicit about the input and output of the transaction. This enables a lot of room for verification. For example, you can check directly the input and output balance of the UTXO transaction without executing it. And you can double check it. You can check it in execution. You can check it just for the transaction. And it enables better parallelism and better scalability. This is because it is immutable. But this talk is about security, so I'm not going to dive in that topic. But UTXO has some other issues, like the most well-known one is the concurrency issue of UTXO model. Probably you guys have heard about it a lot about this issue about UTXO model. Another issue is like you need to learn a new programming model. It's a bit like if you're programming with C or even Rust, and now you kind of need to learn Haskell a little bit. So that's a huge paradigm shift. It's a bit tricky. So to simply speaking, account model is very convenient for computation. It's very close to the model we use every day, and the UTXO model is good for securing digital assets. As we have seen on Bitcoin, there's no on-chain attack on this model. So Alephium, as a new blockchain, we try to combine the strengths of both models, try to improve the by default security of the blockchain. How do we do it? It's actually, the idea is simple. Is we basically decompose the account model into two parts. The first part is asset. The second part is contract states. Right now, for example, if you see the ERC20 token implementation, like both the assets and the contract states, they are based on the storage of the EVM. We went a step further. We tried to use UTXO model to model the assets or the token in the blockchain. So token is first-class citizen in our protocol. You don't need to introduce any extra like standards for it, and it's UTXO based. It means users have full control of all of the output. Even though if the contract is exploited, you still own the token because it's locked by your wallet. And because we combine both together, we don't have the concurrency issues that's happened to other UTXO model blockchain. And also still dev friendly. We spend a lot of effort to focus on the dev experience on our blockchain. Now, let's dive a bit more deeper into the execution of the virtual machine. This is usually the most tricky part. We built, in order to execute this new transaction model, we built a brand new virtual machine with a lot of security considerations. First, why a new virtual machine, not EVM? I think there are two important reasons. The first thing is we are really a new model. It's a bit hard to just modify EVM and use it for our dApps. The second reason is we totally believe that a new virtual machine can provide much more security benefits. Our virtual machine is a stack-based virtual machine like JVM and WASM for safety, reliability, and performance. Because it's based on UTXO model, so execution follows the input-output paradigm. This greatly mitigates the risk of unsafe external costs. Why it is like this? If you are a little bit familiar with the attacks on DeFi, usually you see attacks they kind of use the composability crazily, right? They wrap a lot of operations, contractor costs in one single transaction. But usually, for normal users, you never see this. Normal users is always do some simple operations. So here, actually, the transaction model or execution model gives a lot of advantages for the attackers. But with this input and output paradigm is basically the advantage for attacks is much lesser, and basically we try to make the attacks and the normal users, they are kind of stand at the same line. And because of input-output paradigm, flash loan is not available by design. This is a very controversial design. Flash loan is not totally bad. It has some good use cases as well, but at the same time, it's used for almost all the attacks, on-chain attacks. So in our case, it's not available. This is going to mitigate a lot of the attacks. Probably this could encourage a lot of more white hackers instead of people use flash loan to, just to attack the protocol. And we introduced a built-in asset permission system for contract calls. So you all, I guess you're all familiar with ERC20 token. That's you can kind of approve tokens, but it's not really user-friendly because you need to kind of have one transaction do that in advance, and then and usually for the sake of user experience, you just approve unlimited amount of token for the applications, and that is kind of very dangerous in some cases. But in our case, we have more. We have a built-in access permission system for it. It's more fine-grained. We also have a lot of typical improvements like type checking, overflow, underflow checking stuff. So by default, you have all of these security guarantees. You don't need to kind of import libraries for it. It's going to kind of make the dev experience much nicer. Last is very important thing is we don't have low-level support for map data structure. We use subcontracts instead. These are some very technical details. I'm not going to dive deep into it, but I want to mention here is here with this, because map data structure is usually used to store a lot of personalized data. For example, for the ERC20 token, you have the balance of all of the holders or the owners of the token. If the contract can be compromised, it might have direct access to the balances, right? They can modify, they can steal the coins in some cases. But in our case, it's not possible by default. So that's the overview of like the design. We have a lot of security considerations. And next great topic I want to talk about is minor extractable value on our protocol. This has been like very hot topic in the past year or since the DeFi boom. There's no ideal solution for it, but it's very different on other field. This MEV search space is very different from EVM. So first, the transaction model is based on input and output. So the execution is more fine-grained, as I explained earlier. This means the sandwich attack, on-chain, oracle manipulation, etc. is not possible in a single transaction. As you all know, like on Ethereum, as long as you have enough gas, you can do almost everything on EVM. This is how typically like attacks try to attack a protocol. And because of this fine-grained transaction execution model, the arbitrary usually requires multiple transactions. It means in the past you do it in one transaction to attack the protocol, but here you need to do multiple transactions. And this means you might compete with others. For example, if you need 2 transactions to finish your attack, you prepare the first one and submit the first one. And then for the second one, the other attacks or MEV searchers, they might see it. They would like to compete with you. So this makes the attacks like a bit more risky, and it's good. The third thing is flash loan is not available, so it means MEV is gonna be tricky here. Yeah. Makes basically like kind of make the searchers kind of don't have enough advantage over the normal users. And we also introduce random execution into the virtual machine. So it means the people submit the transactions based on the gas fee. If your gas fee is higher, your transaction will be included in the block with high priority. But there's no guarantee that your transaction will be executed before others. The execution is the auction is based on gas fee, but the execution is not. It's pseudo random. Of course, the miners they have the power to manipulate it. But for normal like people attacks, it's going to be tricky. Yeah, we don't solve it. As we all know, MEV is a tricky question. You cannot really solve it on chain, as far as I know. Yeah. Unless you try to put a lot of very heavy primitives into the protocol. Yeah, so far we have been talking about very low level details. Now let's go to a bit high level and to see how developers can leverage this new protocol or new platform to write secure contracts by default. We propose a new domain DSL language for this purpose. Why we introduce a new language? Because first, as I mentioned, that the model and the virtual machine is different. It's hard to use the existing ones, and we also want to make sure the language to be as simple as possible, and people don't need to learn a lot of things. Or actually, for dApps, a lot of features of a language is not really useful. Yeah. So yeah, the language try to have the low-level VM details and try to enforce good practice by default. Yeah, but this is just trivial stuff. And also we have the built-in syntax for access permission. This is very unique to us. So on the right side of the slides, we have a simple smart contract for DEX. It's very, very simple, but it has something very unique here. You can see the annotation. And this part is our access permission system. So here it is. How do we kind of integrate the access permission system into the language? If you on the first cell of the table, you can use annotations to specify if your function will use access or not, what kind of access you're going to use. And on the second cell is is a user that tries to invoke the function with predefined with assets with tokens. So the virtual machine will check if it's allowed or not. If it's not, then it will just exit. We also have some functions for this. So in the last cell I want to mention is that because of this asset permission system, the reentrancy is not possible for. It's not possible by default if you want to re-enter the same contract in the same transaction. It's not allowed by default. So here is like a very well-known security issues or list for Solidity by Security Boulevard. It's a bit outdated, but it's the best I can find. So first, the reentrancy, as I said, that this is solved by our asset permission system, the input-output paradigm. It's solved very nicely with other new features. The second one, uncheck the external call. This we terminate on exception. And the rest is basically solved directly with the virtual machine. Given the time limits, I'm not going to dive into the details, but you can take picture if you want. So here's the summary of the security. We propose a new paradigm that combines an account model and the UTXO model. The new paradigm creates a lot more room for verification, for defense, and the by default security is much higher. And especially the by default, the default asset security is much higher because everything is in, every token is in UTXO. And we have some improvements on the account model as well. On a side note, I want to mention that our virtual machine is really very efficient, lightweight. Here's an example of a wormhole bridge contract. On our virtual machine is like 1 kilobytes, and on EVM is 10 kilobytes, and on Solana is 1 megabyte. And this is great for virtual machine execution, and it's also use a lot of less computation, the less I/O. So even if we just use this new virtual machine, it's going to improve the scalability by a lot. Yeah, so that's basically the main part of the talk about security. And last, I want to talk a little bit about our project. We started in 2017. We want to build a new sharded blockchain based on a new algorithm called BlockFlow. It was founded before the DeFi boom. We did not expect this model to be a great model for better security on chain, but after several years research, we found that actually our new model and new virtual machine actually improves a lot of things: scalability, security, decentralization, etc. Yeah, we are right now focusing on improving the protocol. So if you are interested in the work, and especially if you are developers, please feel free to check out our GitHub. Try to look at the codes and try to read some of the articles on our blog. I'm pretty sure that if you are an engineer, you're going to be very interested in it. Thank you. Yeah. Yeah.
Thank you, Cheng, for this great presentation. We have time for 1 or 2 questions. Yeah.
I have a question. Like in the classic UTXO model, you have an issue where, like, on each transaction, you have to put all your assets in the transaction. So as you have more assets, your transaction is like uses more and more energy. Like, is it like does this paradigm solve it, or do you have?
So you mean here, the classic one?
Like if you have, I don't know, like 1,000 NFTs, like do you need to like put them in all the inputs every time, or?
Yeah, so here we have some constraints on the number of inputs. So it's a design that you try to be, it's a trade-off here. If you want to support a lot of input in one transaction, or if you don't want to support it. We want to be more conservative on this, so we have a limit on the number of inputs. I think it's around 128. But you can do things in parallel in UTXO model. If you want to distribute like 10K, more than 10K UTXO, you just prepare the transaction in parallel and submit to the network in parallel. So the latency is not an issue, and you still get the high throughput. Yeah.
Okay.
That's it.
Thank you.
Thanks. So I think we're done.
Okay.
Thanks
Thank you.
again, Cheng.
Yeah.